What causes the process of increasing aging and increasing diseases? Here's Dr. Rhonda Patrick briefly explains.
I've been very interested in looking at DNA damage as a biomarker of aging. So as we age, we accumulate more DNA damage. I mentioned it because we're all every time you eat food, you metabolize the food, and byproducts of that metabolism are damaging your DNA. It's just a matter of how much you can repair that damage and how much damage you're actually getting. It's a balancing act. But we can actually measure this in people by using a proxy. It's called phosphorylated histone 2AX, or gamma H2AX. So what happens is immediately after you have damage to your DNA, particularly two-strand breaks, so a double-stranded break in your DNA, this protein gets phosphorylated, and it serves as a marker, a molecular marker, and it amplifies immediately after damage happens because it's signaling to the cell, hey, come on, bring some DNA repair enzymes here, repair this damage. Well, we can use this marker as a proxy for DNA damage. And so for the past 3 years, I've been measuring this marker in people, people that are young, people that are old, people that are lean, people that are obese, as a proxy for looking at health. So the more DNA damage you have, the less healthy you are. DNA damage accumulates in stem cells, and it's associated with aging of your stem cells. So your stem cells start to age quicker, they die, causes them to die quicker. When you deplete your stem cell populations, and it's hard to replenish your cellular populations in a certain organ. And also it's associated with cancer, as I mentioned. So what I found, I've been doing some preliminary work over the past couple of years, is that if you look at lean people that have a body mass index, which is not a great marker for obesity, but it'll do. If they have a BMI of less than 25, and you compare their DNA damage to people that have a BMI of greater than 28, it's almost twice as much DNA damage. These are the same age people, same age, so they should not have, this looks like an old person. Usually you see this much of a difference when you're looking at like a 30-year difference in age. So you're talking about accelerating the aging process on a cellular level, and this is not something that people can see, but it's happening. And what it's going to do is it's going to increase their risk of cancer. It's going to increase their risk of cellular aging, of getting neurodegenerative diseases. But there is a simple solution.